Assalamualaikum student, I am your chemistry teacher and today we are going to start topic boiling point and freezing point of chapter number 5. First of all, we have definition of boiling point. How would you define boiling point? Boiling point, the temperature at which vapor pressure of liquid become equal to atmospheric pressure or any external pressure. So first of all, we will discuss that what is vapor pressure. Vapor pressure is that pressure that is exerted by the vapor of liquid, and when that vapor pressure is equal to external pressure. You have already studied about atmospheric pressure. When the vapor pressure of certain liquid become equal to external pressure, then we say that liquid start boiling, and when you see that liquid, bubbles are producing out of that liquid, so it means that at that point, at certain temperature, that liquid start boil. That temperature is basically known as its boiling point. Next, here you have a diagram. In first case, the evaporation is shown. Look at this diagram. Its lid is open. In this case, when lid is open, the molecule will evaporate outside. Okay, this arrows basically shows that these molecules are evaporating outside the liquid. But in this condition, look at this diagram. In this condition, some liquids are boiling out, some particles are boiling, and after boiling they will escaping out. But when you close that lid, these particles cannot escape that beaker. They will basically returning back. They will collide with the wall of the container, as well as they will return back towards the solution. So basically they are returning back, and the production of these bubbles represent that liquid is at its boiling point. Next, here we have some explanation of boiling point, that how boiling start and which phenomena take place before boiling. So first of all, when the liquid is heated, its molecule gain energy. जब आप किसी भी लिक्विड को हीट करेंगे, उसके मॉलिक्यूल एनर्जी गेन करेंगे. आफ्टर दैट, द काइनेटिक एनर्जी ऑफ मॉलिक्यूल इंक्रीजेस. व्हेन द काइनेटिक एनर्जी ऑफ मॉलिक्यूल इंक्रीजेस, द मॉलिक्यूल कोलाइड विद ईच अदर एज वेल एज विद द वॉल ऑफ कंटेनर. सो व्हेन द मॉलिक्यूल गेन एनर्जी, the molecule become energetic to overcome the intermolecular forces. The energy between these molecules become greater. That's why they become quite energetic, that they break all the intermolecular forces present between them. When the intermolecular forces are broken down, these molecules become free to move due to the rate of evaporation increases. When the intermolecular forces are broken down, these molecules can easily be evaporated. They can escape from the solution. Then what happened? As a result, the rate of vapor pressure increases. When your container is closed, then at that condition, these vapors cannot escape out. They will collide with that lid and return back. When they return back, they will exert a vapor pressure. Okay, so in that condition, first of all, rate of evaporation increases, and then as a result, rate of vapor pressure also increases. Then what happened next? And a stage reaches when the vapor pressure become equal to external pressure. Then its vapor pressure become equal to the external pressure, or we can say that atmospheric pressure, and at that temperature, liquid start boiling. So basically, boiling is that point, is that temperature at which its internal pressure or its vapor pressure become equal to external pressure. So that temperature, that specific temperature, is known as its boiling point. Next, we have certain example. Suppose we have the vapor pressure increase with increase in temperature. It's a truth that whenever you increase the temperature, its vapor pressure also increases. Here we have certain example. Suppose at temperature 0 degrees Celsius, the vapor pressure of certain liquid, diethyl ether, is 200 degrees Celsius, while ethyl alcohol is 25, water is of 5 mm of Hg. So here we have certain example. In this case, diethyl ether, the vapor pressure of diethyl ether is 200 mm of Hg, ethyl alcohol is 25 mm of Hg, and water is 5 mm of Hg. This vapor pressure is measured at 0 degrees Celsius. So what happened next? When heated, when you heat that liquid, then the vapor pressure of diethyl ether, which was 200 mm of Hg, when you heat that liquid, its vapor pressure will increases, and it will increases and become equal to its external pressure at this temperature. It means that at this temperature, 34.6 degrees Celsius, or liquid which is diethyl ether start boiling, because at this temperature its internal pressure or its vapor pressure become equal to its external pressure. Okay, then next point, while the vapor pressure of water is high because the strong intermolecular forces, the vapor pressure of diethyl ether is 34.6, but the boiling point of water is 100 degrees Celsius. Why? Because water contain a very strong intermolecular forces between them. Okay, next we have a graph. This graph shows you have to take temperature at x-axis and vapor pressure at y-axis. Then the curves has been shown to you, and that top line is basically the standard, which is 760 mm of Hg, and this standard is set for mercury to measure the atmospheric pressure at sea level. Whenever you want to measure the atmospheric pressure of certain substances at sea level, then you have to compare it with a 760 mm of Hg. So that top line is of 760 mm of Hg, and now look at the curves that ether will boil at 34.6 degrees Celsius, while next curve is of alcohol boil at 78 degrees Celsius, and the third curve is of water which boil at 100 degrees Celsius. So these three curves shows the boiling point of these three liquids. Okay, next we have factors. Here we have three factors that affect the vapor pressure: nature of liquid, intermolecular forces, and external pressure. We will discuss it detail in one by one. First of all, we have nature of liquid. In this case, polar liquid have high boiling point than non-polar liquid. Why? Because polar liquid have strong intermolecular forces. Whenever there is a strong intermolecular forces, it means it melting and its boiling point will be high. So basically these strong intermolecular forces enable that liquid to boil at high temperature. Next we have intermolecular forces. Substances having strong intermolecular forces have high boiling point. Definitely those substances which have high intermolecular forces, that liquid also have high boiling point. Now this is because the liquid attain a level of vapor pressure equal to external pressure due to its high temperature. Whenever there is high temperature, its intermolecular forces will be high, and whenever intermolecular forces will be high, then it required a lot of temperature to attain equilibrium with external atmospheric pressure. So अगर आपने external atmospheric pressure के equal इसको करना है तो आपको temperature बहुत ज़्यादा चाहिए होगा. So whenever there is a strong intermolecular forces, it will require a great amount of energy, a very high temperature to break these intermolecular forces. That's why those liquid having high intermolecular forces, their boiling point also high. Third factor and the last factor is external pressure. Boiling point increase with increase in external pressure. For example, in case of pressure cooker, when we see the phenomena of pressure cooker, in pressure cooker basically we will increase its atmospheric pressure. So whenever you will increase its atmospheric pressure, its boiling point will also increase. Okay, so the principle of pressure cooker is followed over this, that how external pressure increase, how external pressure basically affect the boiling point. So whenever there is a high external pressure, the boiling point of liquid is also high. Next we have freezing point. So here we will discuss just its definition, and we will check certain freezing point of certain liquids. So how would you define the freezing point? When the liquid are cooled, the vapor pressure of liquid decreases. Obviously when you reduce the temperature, when you decrease the temperature of certain liquid, their vapor pressure also decreases, their evaporation decreases, their vapor pressure automatically decreases. So whenever there is a decrease in vapor pressure of a liquid, when vapor pressure of a liquid state become equal to vapor pressure of a solid state, whenever the vapor pressure of liquid become equal to vapor pressure of solid state, that state is known as its freezing point. So basically at that point, at that temperature, liquid and solid state will coexist in dynamic equilibrium. So at that temperature, below that temperature is the freezing, and above that temperature is melting. So basically liquid and solid will coexist at certain point, and that point at that temperature is known as its freezing point. So here we have a table that is also mentioned in your book. In first column, some names of some liquids are mentioned, such as diethyl ether. Its freezing point is -116 and boiling point is 34.6. Same with ethyl alcohol, its freezing point is -115 and its boiling point is 78 degrees Celsius. Next we have water and N-octane and acetic acid. So all these liquids have their freezing point as well as their boiling point. Thank you.